So the first point of action is we defining our constraint. So 0 xi plus 1, right? That's a summation j is equal to I plus 1 and dj. So now for stage 1, right? For stage 1 or period 1, as the case may be. So as the case may be for period 1, so that would be 0, that would be x 1 plus 1, that is 2, 0, that would be j d what 1 plus 1 2, that's j2 plus what d3 plus d4. You understand? So d1, because it's meant to start from j is equal to I plus 1, where our I is 1 plus 1, that is 2, that's our d2. Then it follows that sequence, 2 plus 1 3, d3, 3 plus 1 4. So x2, our d2 here, this is our d1 and this is our d2. Our d2 is 2 and our d3 is 4. That is 2 plus 4. We do not have any d4, so I didn't have d4 divided. It's to continue in that sequence. So this will now be s2, that's 6. This is our first constraint that's well defined. So for our second constraint, that's q. We need to actually know this formula, especially the second constraint. I prime, that's qi, this is qi prime, where our I is now 1, have you know? So prime is equal to maximum, that's our d was 1, have you know? From this, where is it now? From this from this formula here, can you see di plus di the minimum of di plus 1, our considering period 1, that would be minimum dx2 I 1 plus 1 2, that's a plus minimum x2, right? Then minus max of x1 minus max x1, then comma 0, right? And from our question we are given our what? We are given our x1. From our question we are given our x1 to be 1. From our question we are given our x1 to be 1. If you check very well, our x1 was given to us to be 1. So here now, our max d1, what's our d1? Our d1 here is what? 3. That's 3. Our minimum of x2, do we have any x2? Were we given any s2? Our what's it called, inventory 2, or our inventory of period 2, we're not given any inventory of period 2. That's going to be 0. Maximum of x1, that's the inventory of period 1. Were we given? Yes, we are given. Whether maximum of x1 is still 1, because we are giving here to be 1. So it's going to be 1. That will be comma 0. So you now have your max 3 minus 1, that's 2. That will be 2. That will be 2 comma 0, right? So the maximum of this now is what? 2. That's our q1 prime is equal to 2. So let's do for the second one. That's our q1 prime. And from our formula here, our q1 prime is what? Is equal to max, right? Our D1 is 2, is 3. D1 is 3 plus the maximum of what now? The maximum of x2 minus what? Minimum of x1, comma 0. So max 3 plus, what's our maximum of x2? The maximum of x2 now, we were given our maximum of x2 to be 6. This is our minimum of x2 from what we actually got. Minimum of x2 to be 0. Our maximum of x2 to be what? 6. So we put that here. So minus what? Our minimum of x1. We're giving our x1 from our question to be what? 1. To be what? To be 1. To be 1. So that was minus 1, comma 0. So this one now is what? 3 plus 6, that's 9. 9 minus 1, that's 8, comma 0. The maximum is going to be what? 8. So our Q prime is equal to what? 8. So to write this again now, let's write out our constraint again. Our first constraint now is, yes, okay, 6. While our second constraint will now be what? 2, Q what? 1, right? And then 8. This is 2 constraints we are working with. These are 2 constraints we are working with. In order for us to obtain the quantity we have to produce in meeting our demand while minimizing cost, these are 2 constraints we'll be using. And for this, we are using a forward pass approach. And why are we using forward pass approach? Because the demand are not so much. I think we are having demand of like 40, demand of like 30, demand of like 50. That is when we actually use our backward pass approach. But here we are using our forward back approach. So on to creating our table.